All, welcome to AK App Logics. In the previous video, we have discussed about the number format. This is the part 2 of that particular video. Okay, so I'm gonna discuss how to represent size in numbers. How to represent size in numbers in Verilog. In the previous video, I have discussed the rules for the uh, C language, right? Yeah, this is the rules, right, for the C language, right? C language. So I'm going to discuss how to declare size in numbers, how to discuss how to declare unsigned numbers and all this stuff. Okay. So in this video, I'm going to discuss about the size in numbers. Size in numbers are represented as shown below. Okay, where size is written only in decimal. Okay, that particular size will be written in decimal. This particular point is important. I will discuss important points. Okay. Size is written only in decimal to specify the number of bits in the number. Okay, this particular second point is so important. Where size is written only in decimal to specify the number of bits in the number. I will tell you. Okay, this is the syntax of the size in number format. We have to mention this size, that is how many number of bits are there in the number. That too, we have to represent this particular size in only decimal. Remember this point. We have to what we have to represent size as bits. Number of bits we have to represent in not in binary, not in hexadecimal, not in octal. How many number of bits are there? That particular thing we have to represent in decimal. Okay, we have to use base format. Okay, base more format means it can be either D or capital D for binary, small b or capital B for hexadecimal, small h or capital H for octal, small o or capital O. Specifies what base the number part represents. Okay, so this is also important. So this particular base format decides what the number which is written to the right of this particular base format, what type it is, whether it may be what base system it is, whether it may be decimal or it may be binary or it may be octal or hexadecimal. That particular thing will be decided by this particular base format. Okay, we have to use this tick mark, right? Don't remember this. Okay, this is the syntax. So and now we also we have to use semicolon if we gonna use this in statement. Okay, remember number is specified as consecutive digits from 0 to 9 for decimal base format and 0 to f for hexadecimal. For whereas for sorry, for octal it will be 0 to 7, and for binary it will be 0 to 1. Okay, yeah, let's discuss an example. With that you guys will get a clear idea. So this is 3 tick b 010. If you gonna see the size is 3, it means what we have discussed, size is should be represented in decimal. And what does the size specifies? The number of bits. Remember this point. Size specifies the number of bits, but that particular size should be represented in the decimal. Okay, if you gonna see over here, we have used the binary format, which means the the value or the number that is written next to the base format varies. In this case, it is B, which means binary, is treated as that particular base system. It means 0, 1, 0 are the binary bits. Why we have used the base format as B? So that 0 is treated as 1 bit and 1 is treated as 1 bit and 0 is treated as 1 bit again. So in total we have three number of bits, right? So that particular three we have written over here as size in decimal format. Okay, here we have used binary, right? So that we have considered these as bits. Okay, yeah. If you wanna see the comment, size is 3, base format is binary, and the number is 010, which indicates the value 2, right? The decimal. But whereas the size represents the number of bits, whereas here we have 3 bits. That particular thing should be represented in the decimal, right? So we have used the 3 tick. Okay. The next thing, if you're gonna see here, 3 tick D2. So if you're gonna see the base format, this is D, right? Decimal, right? The number which is next to the base format is belongs to that particular base system. It means here the 2 is belong to the decimal number system. Okay, so how we gonna represent 2 in bits? Why we need to represent 2 in bits? Why? Because the size of the this particular number should be represented in decimal. That particular decimal value indicates the number of bits, right? So if you're gonna see, 2 can be represented as 10, but here I mentioned 3, tick D2. Why means we can mention anything. If you mention, let me, if you mention 4 tick, sorry, yeah, uh, it means 3 tick D2. It means if you gonna present 2 in binary, it will be 10, which is 2 bits, right? But I mentioned here 3 tick D2. Why means it's our choice, okay? But we have to represent what is the minimum number of uh, digits, bits are there. Greater than, if you mention, then the extra zeros will be added. That's it. It means the 2 will actual the 2 is represented as 10, right? Which is a 2 bits. But I have used here 3 as size, right? It means how to make this particular 10 as 3 bits by simply adding the 010 0 to the left side of the 1. Okay, so this represents again 2. This represents again value 2, which consists of 3 bits, right? Right? Yeah, that's the thing I'm gonna discuss. So I hope you understood. Okay, here the point you have to remember is, why not, you may get a doubt as, why not one tick D2? Because there is only two, right? There is only one digit, right? Why having to mention one tick D2? You may get doubt like this. But if you're gonna see over there, the number should be represented in the number of bits only. Okay, and that particular value should be represented in the decimal. So if you're gonna see the base format, here we are gonna use the decimal D. It means the right number to the base format D is decimal, right? Which means 2 is decimal. So we have to must convert that particular 2 into the binary. So we will get the number of bits as 1, 0. Actual the number of bits are 2, but have used the 3. It means we can able to use the 2 actual number of bits or more than that as our wish. If we are gonna use more than that, it may be added 0 or don't care. That's it. Okay, but you shouldn't mention it has one tick D2. If you mention one tick D2, then what will happen means you have mentioned one tick D2, but you have mentioned 2 as a number. Then if you're gonna see in this particular, if you're gonna convert 2 to binary, you will get the result as 1, 0. But you have mentioned size as only 1, which means it will consider only one bit, that is 0. It will not consider 1. Okay, then the value becomes 0, right. It means we have mentioned size as 1, so we have how to represent 2 like this, right. 2 can be represented like this in the form of binary, but you have mentioned size as 1 bit, right. So then it will eliminate this particular one and consider only 0. Is 0 equal to 2? No, right. So you will get an uh, unexpected output. Okay, yeah. The thing is, you always need to represent this particular value in the decimal only. Okay, the decimal only. But the number of bits that needs to be calculated in the binary. Okay, we are not going to calculate number of digits. We are going to uh, find the number of bits. Remember this point. Most of the people confuse over here. So that's I am stressing. So if you're gonna see over here, yeah, there is an H as for base format, X which means hexadecimal. Right to it, there are two digits, two hexadecimal digits. I have mentioned size as 80H. Okay, Y means right to the H, there is two digits which are 70, which will be considered as hexadecimal digits. One hexadecimal digit can be represented into how many binary bits? 4, right? So here there are two hexadecimal digits. Those can be able to represent in 2 into 4 is equal to 8 number of bits. So that the size becomes 8. So we have to mention this particular size either equal to 8 or greater than 8 as your wish. If you're gonna mention either equal to 8 or then the value itself will be written. If you gonna represent greater than 8, then additionally zeros will be added to the left or the don't cares will be added. So about don't care I will discuss. Okay, yeah. If you wanna mention less than 8, then there may be chance of losing your data, as I have explained in the 3 tick D2, right? Yeah. So the fourth one, 9 tick H1FA. Here the size is 9, base format is hexadecimal, and the number is 01FA. Okay. So if you're gonna see this, in the decimal the value will be 506. Uh, ch- uh, don't mind this. So I'm gonna discuss about how to write this particular base one. We're gonna see why in this case we're gonna see after H we have three hexadecimal digits, which means 3 into 4 12, right? We have to mention, as I have said the previous case, we have to mention either 12 or greater than 12 as our size. If we mention 12 as our size, the number which exactly the number of digits will be of that required to that particular number will be taken as size. If we mention greater than 12, uh, we will get some additional zeros or don't cares to the additional amount of size. But here in this case I have used 9. Why? If you're gonna represent this particular 1 FPI in binary, then the number will be 0001 111 and 1010. If you're gonna see I represent this particular number less than 12, then there will be a chance of uh, losing data, right? Previously I have told, right, for the case of 8. But in this particular case, if you're gonna see the 9 digits, those are 0 1 0 1 1 1 1 1 1. If you're gonna count, these will be 9 digits, right? So after 9 digits, if you properly see the value, there are 3 zeros, right? Right? If you remove these particular 3 zeros, did the value change? No, right? If you have this particular 3 zeros, then then it will be 1 FA. If you remove these particular 3 zeros, then also it will be 1 FA, right? For this value only, we have mentioned 90 HF, 90 H1FA. If for suppose if you're gonna have like this 1001, in this case this particular if you remove these particular 3 digits, then the value will be changed. Why? Because there is one over here. This particular last 4 bits will be indicate the value as 9, right? 9. If you remove this particular 3 digits, then the value becomes 1. Means it's not matching. So like this you guys have to think. Okay. Next, 40 HA. H is a hexadecimal base format, and right to the H we have one hexadecimal digit which represents 4 binary bits, which is equal to the 40 D10. Okay. 10, how if you represent in binary, it will be 1010, which is 4 digits. So we have used 40, and 40 B there are 4 digits, 101, 4 bits, 1010. So we have used 4, and for octal 40 0 40 O 12. 12 represents 10 in octal number system. Decimal 10 can be represented in any 4 formats. Okay, like this we can represent it. Next, 8 tick D 234 and 8 tick D capital D 234 are legal. Okay, sir, but you have told that Verilog is a case sensitive, right? So Verilog is a case sensitive means We shouldn't use the variable names as we shouldn't take the consideration like capital A is equal to small a in the case of variables or the identifier names. Okay, where in the case of base formats we can consider small d is equal to capital D. Okay, yeah, 32 tick H FACE underscore 4782 underscore will be used to separate 16-bit number for readability. For our readability in between the number, if there is a huge number, we can able to use the underscore. That option is also there in the Verilog. So if you're gonna see, we have to calculate 1, 2, 3, 4, 5 like that. If you use the underscore, here there is 4, here there is 4. In total 8. 8 into 4, 32 bits. Like this, you can able to understand. It will increase the code readability. Underscore letters are legal for number specifications when base format is hexadecimal. Okay, when base format is hexadecimal, underscore will be legal. Okay, even if you want to use in decimal, it is also legal. Okay, not only for hexadecimal, for also other types of base format also it is legal. Okay, lower case letter valid, uppercase letter valid. In case of hexadecimal, lowercase letters means from A to F we can represent A to F as lowercase. Either we can able to represent them as uppercase as well. Okay, that's the point of this thing. So underscore can be used as a separator between four letters value. Not only four letters, we can also use any number of letters. For suppose I'm gonna use sorry control Z. I'm gonna like use like this. See, I'm gonna use like this. So this is also valid. Okay, this is also valid. Or you gonna use over here. Then no, it is also a valid. Okay, but we will use generally for the four hexadecimal digits separation. Okay, so this is all about the mm, this is all about the size in numbers. The coming next video we gonna discuss about the unsize in numbers. Okay, thank you.